This is just a very recent update on what we were doing in Zambia right before we got here. So a little bit of just sort of explaining what we're doing, and everything that you see is very much preliminary because at most it is 2 weeks old. So who knows? So the scope and the goals. We wanted to look at wind turbine technology and apply it in these rural developing communities. Okay, so certainly a research feasibility kind of thing. We weren't rushing into this a full-blown project, trying to partner directly with an NGO right off the ground. We weren't trying to collect, set up a business, anything like that. So we wanted to test some feasibility. We also wanted to get at least the ground workings for a survey going. So we did a survey. Peter will talk more about how the survey went. And admittedly, it's just very preliminary. Not a whole big sample, but we are just getting engaged with the local community. So we were in the community for about 2 weeks, and we learned a lot about the status of the community then. We also started working with a local NGO, which I'll talk about later. And if I were to add a fourth bullet point to this, I would say it was just an educational and emerging experience for the whole team. We're all pretty new at this, so just going through those cases was good for us. So we traveled to Monze, Zambia. And why Zambia and why Monze, I can answer quickly. We have an emeritus faculty member from my department, who's a Jesuit, and he is in a town that's nearby. My university has had several trips, service learning trips for students in that general vicinity. It was just a soft landing point for us. Very logical to do something like that. So Monze is, I think, a typical small city within Zambia, and the actual deployment of the wind turbine was maybe 6 or 7 miles away from the city. So once you get out here, it's quite rural. Obviously no paved roads, no electricity, no running water, that sort of thing. So we had a nice, comfortable-ish home base here, and we had to come out here to pretty much do our work. Another reason why we stayed here was this is where the hardware stores whatnot were. So strategically, it made a lot of sense. Okay, so the village that the turbine was set up in is called Mioba. Not quite sure if that's the correct spelling of it, but that's what we've interpreted. It's about 60 households, and there's maybe, I don't know, 6 or 7 people on average per household, would you say, Peter? Something like that.
Are you saying something like that?
Yeah, something like that. The partner that we had there, or the partner that I guess we were working through, albeit very loosely at the beginning, and then we started to strengthen the ties with them, is the Diocese of Monze. And they actually have a development office, or an office of development promotion. So these guys, what they do is they try to identify projects to promote development. So they might do some agricultural water, animal husbandry, that sort of thing. They have a strong focus on appropriate technology, and it's run by local Zambians. Everyone there in that office is Zambian. They have a good sense of the community, and it turned out that we probably should have been more tightly coupled with them months before we even left. But this relationship only gelled very recently. So what they did for us is they gave us a facility to work out of that wasn't on site. They identified that the operator of the wind turbine and ongoing, they'll be the project backstop. It's a backstop. So if something doesn't work, they're sort of the first line of defense. They're local, they know the people, they know the operator quite well. So we left feeling that the project would be in good hands, transferring it over to them. So the operator, here's a picture of him and the wind turbine, is George Timba. He's about 42, but he's a young 42, an energetic 42, as you might say. He's got a big family. He is a farmer, and he has all sorts of as a farmer, he sells lots of different things, animals, crops. In addition, he has a small electrical system, which is no more than a 10-watt PV panel. Looks like he has two generators, petrol generators. And he already does some small cell phone charging and 12-volt battery charging from that system, and also sometimes with a generator. but he also takes his stuff into the city to get it charged as well. So it's not exactly clear how that energy balance ever worked out. I think that he always had he probably was short energy, and that's why he had to go to the city for the most part. But he has a relationship with the Diocese. They've trusted him with projects before, and he actually is one of their trainers that trains other people on how to operate wells and that sort of thing. Handy guy, and generally a good person to work around. So if you look at what we did, in addition to the survey, which Peter will talk about, we wanted to look at the technology. We wanted to try our hands out at installing it. We wanted to provide some training to George and his family on the operation of it, and just some education in general on electrical things, energy, and then reporting aspects, which Peter will also talk about. The system was quite simple. It was really easy. A commercially bought wind turbine, which was only 160 watts. You could put it in your suitcase. It's maybe this big, okay? Not more than 20 or 25 pounds. He had an existing solar panel, no nameplate on it. Looked like it was about 10 watts. Could have been 7 watts. I don't know. We gave him a control box that we put together, and it just provides some very basic diagnostic information and a small sealed lead acid battery. So that's really all it was. There were a digital multimeter that he could use to troubleshoot or to do some reporting of quantities. And on the tower, we put an anemometer so we could get some meteorological data, which is important to just assess the area to see if wind is possible. So here are just some pictures of the different components. This is the wind turbine itself. This little arm that you see here is an anemometer. Okay, it's just a cup anemometer.
What is that?
Measures wind speed.
Oh, okay.
Yeah, sorry. Measures wind speed. And this is the tower here. It's about 30 feet tall. Okay. Everything except for the wind turbine, and some of the guy wire and yoke structure we got in country, and it was actually quite easy to do. In fact, it was a lot easier than we ever thought it would be. It didn't take too long to do. It didn't take any special skills. Just pour a little bit of, make a little bit of concrete, and tighten up the guys, and you're essentially good to go.
I'm sorry, did you buy the pole in the country?
Yeah. Exact size that we needed. We didn't actually, we were just confident that we were able to find it. We didn't test beforehand.
It was a little bit of a risk, but
it was a little bit of a risk, but we felt we could make it happen. In worst cases, you have to go to a larger city. But okay, so if you're curious as to the size of this, here's just a diagram of the physical layout. Like I said, the tower itself is about 30 feet tall. There's 4 guy wires around it. They're anchored in just a little bit of cement. We dug a trench, or actually we had to pay the son to dig a trench for us to lay the cable. It's in conduit, nice and protected, keeps it away from the animals and thieves perhaps, and that's all it was. So I think I already talked about these points, but really it could take maybe 3 people, and including having to go and procure the pipes and the things, maybe 3 days. And we could have locally sourced the guy wires and the yoke there as well. We just brought them with us because we weren't sure, but it wouldn't have been that too difficult to do. So pretty easy to do, actually. Not prohibitive. If you want to know how much this thing costs, here are the main, what I would consider the main components. Of course, this isn't exhaustive. There are other nuts and bolts and things like that go into it. And in this column, it's whether or not we got it in Monze. I would say that the metering, and again, the yoke and the guy wires, we could have found in Monze are not too far out of it. So mostly found locally, not too difficult to do. And after I get a chance to go through all the receipts, I'll make a little bit more of a detailed list. Okay. So training, we obviously wanted to not just leave the wind turbine and walk away. So we went through training. We were on his property for close to 2 weeks. Not every day, but we had a lot of opportunity to work with George, his son, and even his family to do training. And not just on our particular system, but how to use a digital multimeter, how to check the condition of a lead acid battery, all these things that are just general good knowledge for somebody to know if they have a system. So more or less what we went over over the course of the time. So some very early lessons that we've learned is, the wind turbine we bought, that was about $650, very overdesigned. Small wind is designed originally for basically the yacht market, right? So these are people wealthy, they want to plug and play, forget about it, needs to be resistant to corrosion, all these things. Way over designed, and in fact, it was almost to the detriment of the system because it was very difficult to explain the complex controls that the microcontroller had inside the wind turbine. But the wind turbine itself behaved easily. I mean, it went off without a hitch. It rectifies it, so it's just DC. It will have its own charge controller, so it knows when to stop charging the batteries. All of this integrated into the same form, so that was very nice. If we were to do it again, we would make some adjustments to the controller box, but that really wasn't the focus of the trip. This was a necessity, and we put it together and didn't spend a whole lot of time engineering it. We did bring one of the home lighting kits that have been deployed in Haiti, and oh my God, did they love that. It broke my heart, and Peter's heart, to have to take it, to bring it here, to find that you already brought one. They had actually said that, we how much would you pay for this? And he was like, well, $100 if you came after the harvest.
Yeah, he was saying, yeah, I'd have to plan for it, but in April, he wants one.
Yeah, he liked the idea of being able to take it when they do different religious services around to have a light. Yeah.
That's very cool.
Right, so they were very sad to see that go. But, I mean, if anything, it's a very loose indicator of the market for that, or the desirability for something like
Go to
that.
Zambia.
Yeah. So,
Did you have a light kit with it?
Actually,
yeah, and the light kit with it.
So where's the light kit?
It's in my hotel room.
Actually, right.
Yeah.
So
The thing here, the other day didn't have the light.
It was just sitting in the box there.
I haven't opened the box since I got here now. Yeah.
I just got an email from a guy from Zambia wanting us to connect through that Texas carbon market.
Oh, wonderful.
Once this project brought there.
Wonderful. Maybe there's sounds like there could be some synergies here.
He suggested we might charge customers and that it might be a business that we should consider.
Yeah.
That's a good idea.
Yeah. What did we think of
Why
that?
don't we toss that around?
Okay.
No idea.
Yeah. So education to the local community on, I mean, outside of what we might do with home battery kits and solar trailers, nobody knows how to maintain a lead acid battery, and boy, it would be interesting to see at what cost it is. If people actually, if we gave the people the education, the tools to monitor their own batteries, there's already battery charging going on. That in itself would probably have a significant impact on the situation there. So hopefully,
There's a block here for my farm schools. We have previous transparency talking about basic mechanical, basic civil, basic electrical. And the next the next slide is talking about more education on battery, more education on loads. Those are the basic skills we are finding out that people need in the villages and they don't have.
yeah. So again, a battery to anyone that's not an electrical engineer or chemical engineer is a big black
It's a
box
big black box.
of chemicals, and you have no idea what goes on inside it. It's all nonlinear, it's all hard to explain, and everyone is different, right? So they all behave differently. It's very complicated. So a lot of work can be done here. Also on loads, people will buy incandescent bulbs because they're a third of the cost of a compact fluorescent, and then boom, they shoot their, that's all their energy goes into the incandescent light. No idea that there's differences in these sort of things, or appreciate the quantity or the magnitude of the differences. So this is just a short list of some quick lessons. I'm going to turn it over to Peter now to talk about the reporting that we did.
Okay, so the reporting side of it was basically how can we get some information coming back to us and learn from us? Given that we have a limited amount of time to devise a reporting strategy. And so this is basically what we wanted to try and get back. The wind turbine condition, we want to know if it breaks or something catastrophic happens. get some information on the wind speed data, although not perfect. At least something is better than nothing. Look at the wind turbine charging current, get an idea of if you had a wind turbine operating at its full capacity here in this location, how much charging could you actually get done? Actually, it would have been nice to have a data logger there too, where we could say over the course of the day how many amp hours per charge. And then to just keep an eye on the battery and the battery voltage and how they use the battery, how far it goes down, even though we did give some training. The reporting, well, it was lowish tech. We have a logbook with some columns, and we have an SMS coming 3 times a day to the U.S. We've purchased a phone for very cheap and enough credit so that he can send it to the U.S. Turns out to only be about $120 or about $100 a year for that. We have them going out to measure the wind speed based on hertz. So there's a bit of training on how to measure something properly, how to measure battery voltage properly as well. So this would be an example of, these are actually what we've gotten so far. This would be a sample SMS. So we have some delineators there. We chose the question mark because they didn't know it anyways, and we don't know what it is. No. We chose the question mark because it was just the easiest symbol to use on the phone. It was 2 instead of 4 presses. Yeah, delineator. And so what we were asking for was the date, the time, the wind speed. This was hertz. Wind turbine current and amps. External recharge was a question, yes or no. Has he taken it into town to get it externally recharged, or has he recharged it with his diesel generator? The battery voltage and which battery? The 100 amp hour battery, or the 7.2 amp hour battery, the 28 amp hour battery, or the battery that he buys next if something breaks. And then just to keep an eye on the solar charge, this should only be one in the middle of the day. Otherwise, we don't have very much precision on that one. So it's like the analog meter says either 0 or it's close to 1. So that's what we have. That's not even very important here.
What is wind speed and grid speed? Is that RPM?
No, it's
It's how many times the anemometer goes around in a second.
Frequency at which
RPS.
No.
RPS in the end.
No, it might not even be that. It's a calibrated anemometer. You actually take the hertz and you put it into an equation and it converts it to wind speed. So I don't know how many poles there might be inside the anemometer, so you can't say it's necessarily RPM.
I calculated this here, and it was about, I think it was about 12 miles an hour, 15 miles an hour, something like that. But these are just a few.
I know it's right, but
Yeah.
it'd be nice to know what the wind speeds are.
Oh, yeah, we
There's just a little
yeah,
calculation.
it's
to do.
just an equation.
I can show you after. But, again, this is just a few readings, so you can't even begin to come close to trying to project numbers.
What is that you need for that wind turbine?
Charging current,
Yeah. What's the end?
that's an amps. So if you want to go back one.
Yeah, the wind turbine current.
Yes. So charging.
That's an amperes.
Yes.
It's just an instantaneous value that he reads.
And this is DC output.
Yeah.
12 volts.
So here's our phone. Again, the total cost was $125. The yearly cost is actually about $100. One is he has a phone that we can call. And I will call next week, actually.
So 125 includes international transmission.
Yeah.
That's fantastic.
Yeah. Let's see. Okay, so if there's any unusual items, the turbine breaks, the tower buckles, the battery explodes, anything like that, then we have instructions to contact us. And we have, if we can, we created a user guide for them. So first thing is, can we refer to something in the user guide that gives them some instructions and pictures, because it has pictures. The second, we can call them by Skype and try to walk them through it. The third, we have through the Diocese, there's a retired father there, Father Bert, who's in the EE faculty, so we needed him to go and do some a little bit more troubleshooting, then we could do that. So here's a few positives and negatives of the reporting so far. It is easy and cheap to implement, and with very little planning, you can do something like this too. The training was, I think, pretty limited, just a couple of days. It may not be enough, but we've at least gotten it started. That you can also see that's a weakness. You do have to do a bit of training, and we're not really sure if that was the right amount, but went through it several times. We have direct line of contact, and we have 2 different modes: primary, so we get data right away, and then a logbook, which will have the Diocese scan quarterly to give us that data back. Weaknesses: 3 measurements a day. It'd be nice to have more. We have limited data categories. It'd be nice to expand that out. The training needed to prevent mistakes. There's data entry mistakes there. There's all sorts of mistakes if you're just reading from a multimeter and things are going up and down, so it's not totally accurate. It'd be nice to have synchronized data. So right now the process is you have to go out, measure the wind speed, and then you have to walk back in, measure the charging current, you have to measure the battery voltage. It'd be nice to get all that time stamped at one time. It is a snapshot, it's not a running total. So what is the amp hours per day that have been created or charged? How much load at different times of the day? What's the draw on the battery? And it is time consuming. They said that it should be fine if you do it fast. It's only 5 minutes, but it is 3 times a day. Somebody has to do it. So improvements for next time: robustness. Let's have synchronized data, more technical data categories. What's the ambient temperature? If there's any tire vibration? What's the load current, for example? If there's any way to incorporate non-technical data, what I'd like to know is how is he using that energy to start a business, do more charging, make money? How is he using it to, how are his kids using that energy to study more, or things like this? More often, having data logging. It'd be nice to automate that with SMS technology. Kind of similar to what you're talking about, putting in a unit that automatically sends us data, that we have a database that captures it and analyzes it so we can just see what's going on that unit. Talk about more contact in person, so strengthening the relationships with the diocese so that there's contact in person, and that it's valuable contact. How can we make it valuable for the community, for George himself, for the whole program? Incentivizing reporting, if it's a question mark, do we need to? And yeah, measurements to analyze full socioeconomic impact. That's a big question I have. Okay, these are general risks. With how we're looking at the whole project right now, there's risk that the battery and the technology fails. There's risks with intermittent or erroneous reporting, or all of a sudden the reporting just stops for some reason. And the wind is the big question, you know. Is the wind higher or lower than what we expected? If it's higher, that's great, but if it's lower, then it could have good, very important implications on building a business model with community-based wind. So, in addition to installing the wind turbine, doing the reporting, we also conducted a very informal and initial market survey. There's actually 2 surveys. A household pilot survey, we had some questions we wanted to ask households, and we had a more general go into the city and ask businesses how they do charging, get an idea of what the market is for cell phone charging and 12-volt battery charging. For the household pilot survey, we had about 10 houses, and with the basic market survey, it was over the course of a few days, so we were talking with a number of businesses and going through the market. That was in Monze. These are the components of the household survey. Pretty straightforward. I think what was most useful for us was looking at the occupational data and income. And they're mainly farmers, so what we would do is actually go through each crop they had, how much they sold last year, how much they sold it for. It is, they're remembering from last year, so it could not be very accurate, but it gave us an idea. And the household energy use, where we would ask them every single, if they have a torch in the house, a lamp, a room light, DVD, a TV, how many hours per day did they use it, how often, what powered it, if it was kerosene or if it was, in most cases it was D batteries, how often they had to buy new ones, how much that cost. And so we kind of got, okay, in a year this is how much they would spend on cell phone charging and buying batteries and recharging 12-volt batteries. And if they do any power generation themselves, if they have solar panels. This was just kind of some ideas of what would be valuable. So we changed the survey through, like halfway through to say, okay, we don't need to ask questions about this anymore. This is not, like we were thinking we should ask about what sort of financing that they have. It's not important right now. So that was, it was actually for our knowledge of how to do the survey in the field. Here's the initial results. We learned about the devices at home, which I mentioned. We learned about the daily uses. Calculating out for these 10 households, it was about $180 a year in electricity, either D batteries, charging 12-volt batteries, charging cell phones. The cost for charging a cell phone would be about $100 a year a household would spend. 12-volt batteries, if they had one, would be $60 a year. And for these households, the average income apparently was about $2,300 a year. Just for your information, about 44% of the households had a PV panel and 33 had a 12-volt battery. One person had a PV panel, no 12-volt battery, was charging a radio directly. So this is the households. This is George's family. He has a family of 11. They're mainly farmers there, so they're big families. We met some households with 17, 21 people, several wives. And this is what the devices look like. It's just a board off the ground. You've got the inverter here. You've got a power strip. You're charging cell phones. Here's a little battery. Here's what the LED lights look like. They've got their TV, their DVD players down there. And that's another battery that they have. This is like George's house, so he's got 12-volt batteries.
So he's got a group power?
No.
So he's just charging everything from the battery, and that battery goes charge something else.
Yeah, either before we were there with the solar panel, a very small one, or he would charge it in town. Now we've got the wind turbine, so that's what he's using.
And that's 100 watt unit, you said?
160.
60.
160. So here's a few just basic calculations that it's only 10 families, so it doesn't really mean that much. Bioga Village has 60 households. If you have $180 per household spent on electricity, then that's $10,000 per year. Is that something that we can start out with for a market for these types of CSI products? Casilla Village next door has 85 households. Again, the same calculation, 15,000. If it's the same sort of service, lighting and cell phone charging, does that fit within the solar trailer or the wind turbine model?
I think that charge is about twice what you're charging to and more. Yeah.
So this would be what they currently spend, right? So
Yeah, I don't think the Haitians spend incomes like this,
No.
$2,300 a year.
I mean, if you're asking the question, I can tell you, like, those numbers totally subject to what your fully employed costs are, which comes down to transportation and customs costs.
And
Well, what I'm thinking of is if you had a family paying $625 per month for 60 households, does that fit within their budget? That's the question I want to know. If you just plopped it in Neola Village, could they pay that? And this is not bad information as I see it. I say, okay, here's something.
That's pretty good.
Yeah, it's good. Yeah. But again, it's only 10 households, so we don't really know that much. Okay, so here's a few criticisms. What is the purpose of the survey? Why are we doing this? Well, we're learning, first of all. Second of all, we want to build up a case for a market that involves CSI products. We'd like to have greater quantity, talk about statistical significance, and how to mitigate biases, like someone wanting to say that they actually have more money than they do, things like that. So we didn't pay any attention to that. So the basic market survey, like I said, we went through town and we talked with people charging cell phones and charging 12-volt batteries. And what we wanted to know is what is the market like for 12-volt battery and cell phone charging in Monze. Cell phones are charged at about 40 cents a charge. That's 2,000 pin in Zambia. And the 12-volt batteries are either 3,000 or 4,000 depending on how many hours you have it hooked up.
This, real quick, gives you an idea of the disconnect between the energy, right? Because a cell phone is 5 watt hours maybe, and a battery might be a kilowatt hour, but they're only charging 20 cents more for that difference, right?
Yeah.
So,
Right. And so like Henry was saying, the education and how to maintain and how to understand how batteries work just was not there.
So where do the market look like?
yeah, that's exactly right.
And then all that was coming primarily from grid power. That's people go into the city, they get it charged, and then they bring it back out to the village.
Who do they pay when they went to the city?
I'll look at that in a second.
That big battery.
Cell phone charging, villagers coming in Bioga, it's about 2 hours, maybe a little less, maybe a little more. Each way, they charge cell phones while they're off doing other things to try and make it a little more convenient. You ask anyone, well, it's really inconvenient. They don't like having to do that. So that's an obvious answer.
Price discrepancy, but people value cell phones more. More people use
Exactly.
cell phones. Jacks up the price compared to.
It also might be that the average 12-volt battery is in such poor condition that they don't
Here's another disconnect. Is you can charge it for 15 minutes or 6 hours on your cell phone. It's still 2,000. Doesn't matter. You know, that's just people don't understand how the charging. Sometimes it's an issue of convenience. You know, I gotta go now, but it's always 2,000. Let's see. And then something that we noticed that if they do have a 12-volt battery, they tend to do some of the charging at home. 12-volt battery, there was only a couple places in town that did it, and it was highly questionable. They made their own transformers, stepped down the voltage, there was no measurements. They basically, the most reputable one, he hooked up a bunch in parallel without checking anything in terms of what the battery voltage is, left it for a little while, and called it done.
So essentially,
Averaged it out.
these are batteries of different capacities, different conditions, brought in at different voltage levels, and you just, it's sort of like survival of the fittest when they hook up the, and these are repurposed, well, some of them are repurposed rectifiers from transportation systems. It's really, they looked like they were probably 40 years old. They had a big fan trying to cool them, and he described the process to me as he kind of looks at the battery and sees if he needs to get out the big nasty charger, or if the smaller ones can make. So I think you would take a battery that, I mean, it's not a death sentence to take a battery there, but there's no TLC involved. It's just, we're going to turn it on and let it go.
So yeah, the customers also don't know what's going on either. They show up if it's charged, if it's not, how much of a charge they get. These things are just big black boxes. So here's one profile. Isaac was the beautiful guy that we went to. He actually knew, we could ask him, do you check what the amp hours are? And he says, no, I don't check it. It was clear that he understood some basics about electricity, no doubt, but the market didn't really require him to, in my opinion, the market didn't really, nobody had asked him, is my battery getting charged properly? They just said, okay, thank you, here's the money. So he doesn't have to explain it to people, he doesn't have to, hold it up to that standard. So for him, his charging business evolved out of an auto garage. He was recharging car batteries that had gone flat, and it became, at this point, I think in the wet season, he charges something like 100 batteries a day, usually around 15 to 20 a day. So it does provide enough income for him to pay for his electricity bills for his garage as well as 2 other buildings. So it's a significant source of income for him. And most of them are clientele villagers coming in, and a few are car batteries are pretty much right here. So then the next question is, how do we get to the point where we're building a business plan for Zambia around some sort of a product or another, either wind turbine or solar trailer? We need to start, first of all, getting a better handle on what the wind speed data is, what we can expect out of charging, and what the patterns are. Are we going to have big 10-day long breaks of wind where there's no wind at all? Okay, or is it consistent? Or is this the particular location actually be better to have more locations where we measure the wind speed? This will give us a bit of experience on what the year-long wind speed is going to be. I'd like to know, okay, if we know what the wind speed is and the charging current, what you could potentially charge and how much you actually charge. So how good is that person at converting that into usable electricity? And then even further, how do you convert that into monetized activities? And to continue scoping out the pricing for products and services, pretty much everywhere we asked, 2,000 kwacha was the price for a cell phone charge. So we have a bit of this information. Doing a survey that's more systematic and relevant is, I think, the next step, building upon what we've done. And indeed, if we do another survey involving Zambians to do the survey. Calculating a payback period, financing, all that stuff comes later, but this is, the start of it here.
So all this is a 160 watt generator, which is less than one solar panel. So what's the cost comparison with a solar panel, or why is there an advantage to using a wind turbine over a solar panel?
Well, there certainly might not be.
Yeah, we're not assuming that there is. We're
No.
just testing.
No, I'm just raising this since you got into the economics here.
Why did you pick wind? Is Zambia known for wind resources?
No, it was actually because we had the link there before. We chose that place. And it wasn't, I don't think it was very systematic in the way we chose it. Somebody knew that this place has pretty good wind.
Exactly. So, like I said at the beginning, okay, so let's gain some information, some experience about using wind in these situations. So rather than trying to deploy a 2 kilowatt wind system, let's just keep it simple.
I'm with you on that.
I hope that you also saw, that jumps out at me as I listen to both of you speak, that you saw the raw intelligence that is there in the village. Just those people doing all of what you described them doing without any formal training.
Yes.
And then imagine that is not happening only in that village. All across this land, there are people like that in small villages who are just using their giftedness to do some magnificent things.
It's pretty amazing.
Then imagine what would happen if those people could be given even a modest amount of some formal training.
Well, yeah, I think harnessing the skills that are there, and at least establishing and making the best use of it, but also thinking of in the long term. The long term view is how do you keep that, and how do you build upon that? And how does that also, how is it self-generated? How is it, I want to teach them how to do this one thing, but in Zambia, it should be self-generated as well.
One other comment is, after we put up this wind turbine, we sat around some Monze, which is their local beer, and said, okay, how could we do this better? And we came up with all 10 different ways of, okay, well, you know, instead of, hire a car to go to the village, drive the 6 miles, load up the batteries, take it back to Issac and charge it there. Okay, I mean that cost, it pencils out. I think that would be that's a very simple way to do that, right? No buying solar panels, no $10,000-$20,000 investments. It should be pretty easy to do. The grid is there. It's not on all the time, but it could be done. There's lots of other different ways of doing that. Maybe if the goal was to you know, have greater access to energy, you could probably look at Issac's setup and make it more efficient. Maybe drive the cost of charging batteries lower, or maybe it's the solar trailer is a better idea. But in this particular location, the grid is pretty close, so let's trade, you know, tires of a vehicle for electrical wires. You know, just commute back and forth. Why not?
Well, time, work time, I mean, you're losing work time, you're running around.
Yeah, to have somebody come all the way back. I mean, if you hire a driver, you could go out there, people could walk to the nearest road, you could have a kiosk or something. Somebody will drive you there and back for a couple of bucks, and that's it. And electricity from the grid is extremely cheap. We're not talking having to charge a couple bucks a kilowatt hour, it's cents a kilowatt hour. That component, the energy component of this operation would be like nothing. You'd be paying for maybe a shop connection to your storefront and a driver that drove back and forth 3 times a week. I mean, it would be very.
I think at this point it's important to, like, we need to keep coming up with these ideas and also have some time to think about what we learned here today as well. But then try to break it down into which ones do we want to pursue. So that's where I'm at. But I think all those, everything you said is a valid point. Worth.
Didn't one of your slides say that a lot of people had PV solar panels?
Well,
in the sample that we had, there was 44% that had solar panels. All of them, none of them were over 10 watts.
they're all small.
Not over what?
10 watts.
Yeah.
So it's very, very small. And there wasn't even the knowledge of how to use them properly. So if they had a 12-volt battery, they were charging, they were leaving it connected overnight, it was discharging.
Yeah, George would leave his his strategy was to put it in the hottest place. That's how he would try to get the most power, which is, you want to put it in the sunniest place that's also the coolest, right?
Yeah.
You don't like them hot.
But another question is, okay, if we just took the $1,400 and bought solar panels and did the same exact thing, is that a better result? I think that's a fair question to ask.
Well, I'll tell you, one thing that's right about it is, it's not going to fail mechanically. It might burn out, but it's not going to fail mechanically.
I agree that we need to look at and weigh all those things, but without any information on wind, we can't make any good explanation. That's why we have to do this.
And this was your first endeavor, your first effort out here. You had a turbine that was too expensive. You can buy cheaper ones, doesn't have quite as many bells.
Yes.
You know, your proximity to the grid is a huge factor. You know, it's like we don't push some lasers near the grid, except for like the UEP program, which is specifically an end of grid application and customized for that. So one concept, one business plan, one set of point, not appropriate.
Right.
Yeah.
Yeah, I always thought when I very first modeled this thing, before there was a sunblazer, we had a model of a station, a community-sized station. And I thought the ideal combo would be like, I priced it out this way, 50% wind, 50% solar. The idea being in normal thermodynamics, you get wind when at night, dawn and dusk mainly. And then you get the sun during the day, and you want to capture everything you can in that location, then that combination is really nice. But then I get worried about 30-foot towers with anything big on it. Now you got a little thing up there, that doesn't look so intimidating, but when you start thinking
The
size.
tower was the easiest part, honestly.
Yes,
But the mobility of it, actually, you could take it down without too much trouble.
well, except it's a tiny lightning rod and stuff like that.
Yeah, you have to ground it, we grounded it.
There's a product liability issue.
tenant above it.
Yeah.
Yeah, my rule of thumb is if the turbine is not spending 30% of the time or more,
Yeah.
you can't compete with solar PV.
Well, yeah, the capacity factor of solar is usually less than 20%.
20 to 22, 25, depending on where.
25 would be high for solar. For wind, on a commercial scale anyway, 30% is sort of the
Yeah,
benchmark.
yeah.
So,
The high wind places
But-
are 50, the 40.
look, it's all about the resource, right? If you're in an extremely windy area,
Right.
use wind.
Yeah, Columbia Gorge is really good.
Yeah, right. So we obviously this was not the Columbia Gorge, but it was windy.
Did you look at the available weather station by the local airport or?
There's hardly.
There's nothing?
Yeah.
It was too big a square, right? So,
Yeah. Local terrain is.
My company deployed a lot of solar power weather station, cell technology. We have the most density in terms of weather station for fire detection in the US. So we have lots of weather stations that we have a lot of technology that are, any interest.
yeah, definitely. I think when considering scaling up on these types of projects, especially with wind, the process that you go through to appraise a certain location that has enough wind we have to advance that quite a bit. And right now, we didn't. It'd be nice to have ongoing wind data every 10 seconds for a year at different heights. Okay, what's right for a community though is my question. How can we get it to the point where a community or a person can say, with wind, with a limited amount of money and time, that this is a good wind resource that we should follow up on, right?
Yeah, it could be in this particular location. It could be it could be some low-hanging fruit when it comes to rural electrification because it is so close to the grid that if you want to make, impact per dollar, the grid is right there. But maybe that's not right. But if we think of it in that terms, it could be a higher return for a lower investment.
Okay, well, I think it's time to do the break, and thanks again, gentlemen.
Thanks.
Thank you.